Alright, welcome to the Algebra 2 square root and inverses review. Alright, so on 1 through 6 it says match each graph to its equation, state the transformations, vertex, and domain and range. So let's look at number 1. So on number 1, let's get the vertex first. It's at -1, -2. Then let's try to find an equation that shows -1, -2 for the vertex. So I have two options here. They both show -1, -2, but this one has a negative, which represents reflection over the x-axis. This one doesn't reflect, so it's going to be I. Right, so again, this one is not upside down. It's a good square root, but it's shifted left 1 down 2. So left 1 down 2. Right, then for the domain, from left to right, we start at -1, and then it continues going to infinity. And then for the range, if I start at the bottom and move my way up, the graph starts at -2 and then continues going to infinity. So this would have a range of -2 to infinity. Alright, so then number 2. Number 2 has a vertex at 0, -2. Right, so this just has a shift down 2. So something that goes down 2 would be B. With another rock spot. 0, -2, and then this would be the transformations. Right, so down 2. Domain would be from 0 to infinity. Range would be from -2 to infinity. Alright, then for number 3, we can see this graph is upside down. It's reflected over the x-axis. So it's a vertical reflection or reflection over the x. That would be option G, so that negative is a reflection over the x. The vertex is at 0, 0. Domain would be from 0 to infinity. Range would be from -infinity to 0. Alright, so make sure you recognize this for the range. If your graph is reflected over the x, it's upside down. So the range starts at -infinity, stops at 0. Right, then for number 4, the transformations, we see that we go right 1 up 2, so the vertex is at 1, 2. Right, so what would have a vertex at 1, 2? Right, that would be H. Right, so we go right 1 up 2. And then for the domain, we got 1 to infinity. For the range, we got 2 to infinity. That was H. So for number 5, and if I graph the parent function, right, this one would be the parent function right here. You see that this one's a little bit higher than the parent function, so this one's being expanded by a factor of 2. So we got to find something that has a vertical expansion by 2, which would be E. Right, so this is a vertical expansion by 2. Right, the vertex would be at 0, 0. Domain would be from 0 to infinity. Range would be from 0 to infinity. Alright, so then for number 6, we got 0, 2 for the vertex. Alright, this one only shifts up 2. So let's see something that shows going up 2. Alright, that's down 2. This one's left 2. This one shows going up 2. So that's A. Alright, and then for the domain, we would go from 0 to infinity. Range from bottom up, start at 2, and then it keeps going up to infinity. Okay, so let's go to the next page. Alright, so on this page we are just given, so we're given the description, we have to write the equation for that description. So on 7 it says translates the parent function down 3 reflects over the x. So y equals, this reflection means we need a negative in the front. Down 3 means we need minus 3 on the outside. So negative square root of x minus 3. Number 8, the transformed graph has a vertex of 4, negative 8. So they gave us h, they gave us k. And so since h is 4, we need to have x minus 4 on the inside, because remember the inside is the opposite. And then k is negative 8, so minus 8. So that would give you a vertex of 4, negative 8. Number 9, dilates the parent function vertically by a factor of 3/4 and translates right 7. Alright, so 3/4, that would be the a value, so vertical compression. And then if we want to go right 7, we need x minus 7 inside the square root. Alright, so then for number 10, 11, 12, this is on inverses. So find the inverse equation of each function below, graph both the original and inverse equation, then fill in the requested information. Alright, so for number 10, we have 2x plus 5. Alright, so we got 2x plus 5, so then this has a y-intercept of 5 and then a slope of 2. So let me get the straight edge. So we got so that's the original one. This is a straight linear line, so domain and range would just be all real numbers. Right, now to find the inverse, you would switch x and y, and then solve for y. So subtract 5, then divide by 2. So our inverse is x minus 5 over 2. Alright, so now let's graph this one. So you could type this into the calculator, get the points. Alright, someone's going to get a couple points. There's a point at 5, 0. What else? That's 7, 1. And then also we know the slope, it's 1 over 2, so let me just follow that slope, 1 over 2. So go up 1, right 2, up 1, right 2. Alright, so that's the inverse, and then domain and range, they just switch, but they're both the same, so negative infinity to infinity. Alright, then for number 11, same thing. This is going to be a parabola, this is a quadratic. Vertex is at 0, negative 2. Right 1, up 1, right 2, up 4. Again, you can just plug this into the calculator, get the points. You could also follow the pattern. You go start at the vertex, go right 1, up 1, right 2, up 4, right 3, up 9. Right, and then this is a parabola, so the domain should be all real numbers, but the range would be from negative 2 to infinity. Alright, so now let's find the inverse. So switch x and y. Solve for y, so add 2. Square root both sides, we get y for the inverse is plus or minus x plus 2. Alright, don't forget to put this plus or minus. Alright, so to get the inverse, you could just take the points that you have and then just switch them. So here, let's see some of the points we have. We have negative 3, 7. If I switch that, that's 7, negative 3. We have negative 2, 2. If I switch that, we got 2, negative 2. 0, negative 2. Flip that, that's negative 2, 0. Let's see if I'm missing one. Negative 1 would still be negative 1, negative 1. Alright, so then on this side, 1, negative 1 would be negative 1, 1. Again, all we're doing is switching the x and y's. 2, 2 would still be 2, 2. 3, 7 would end up being 7, 3. Alright, so the domain here would be from negative 2 to infinity. Alright, so bracket negative 2, and then the range would be from negative infinity to infinity. Right, so then number 12, same thing. We have a starting point at 5, 0. Have a point at 6, 1. Have another point at 9, 2. Right, you can get that from the calculator. Domain would be from 5 to infinity. Range would be from 0 to infinity. Right, so now for the inverse. Start off by switching the x and y. Go ahead and square both sides. We get x squared equals y minus 5. And then add 5. Alright, so this is going to be the inverse. If you want to graph the inverse, just take those 3 points that we got, flip their x and y's. So here we have 5, 0. If I flip that, that's 0, 5. Here I have 6, 2. If I flip that, that's 2, 6. Sorry, no, 6. Sorry, this is 6, 1. So it should be 1, 6. That's my bad. So 1, 6. And then we got 9, 2, so that's at 2, 9. Right, so on this inverse, we got back a quadratic, so it needs a domain restriction. Right, because right now, the domain, you would say, would be negative infinity to infinity, because this makes a whole parabola. But we cut it in half for the inverse, so the domain would have to be at 0 to infinity for us to just get this half right here. Also, you could tell because these two just switch, so the domain has to be 0 to infinity because the range of the original is 0 to infinity, and then this would just be 5 to infinity. Right, so again, this is technically a full parabola, but we cut it in half, we restrict the domain because only the right side is considered the inverse of this. Alright, so then number 13, same thing. Go ahead, switch the x and y. This one says, given the function y equals x squared minus 3, find the inverse, or find the equation for the inverse function algebraically. So switch the x and y, add 3 to both sides, square root. We get plus or minus square root of x plus 3. Then for these next 5, we are solving for x. So it says solve the following radical equations, show all work, be sure to check your solutions, and eliminate any extraneous solutions. Alright, so step 1, let's get the square root by itself. So on number 14, we need to divide by 2. We get square root of x plus 1 equals 7. Then we got to square both sides. Right, square both sides, this becomes x plus 1, this becomes 49, subtract the 1, x equals 48. Alright, so let's confirm this works. So for y1, I'm going to put 2 square root of x plus 1, 14 for y2, go to the table, let's skip to 48. They both have the same y1, y2, so that works. Right, so for number 15, square both sides. Right, so the square root's already by itself, so I go ahead and square both sides. We get 4x plus 12 equals x squared. Right, so here we have an x squared. So let's move the 4x and 12 to the other side. so it's equal to 0. Right, because we have x squared, we have an x, we have just a constant, we know we can make a trinomial out of this, and then we're going to have to factor this. All right, so if we factor this, we got to find two numbers that multiply to negative 12, add up to negative 4. That would be x, let's see, or two numbers would be negative 6 and 2. And if you set them equal to 0, we should get x equals negative 2 and 6. Right, so set these equal to each other. Let me do it up here. X minus 6 equals 0. X plus 2 equals 0. X equals 6. X equals negative 2. Alright, so now let's check if these work. Okay, so let's go to negative 2. So negative 2, we have 2 negative 2, so that doesn't work. Negative 2 is extraneous, and let's see if 6 is good. Alright, 6 has, yeah, y1 and y2 are both the same, so that works. So the only solution here is the 6. Alright, then for number 16, this is a cubed root. Go ahead and divide the 5. Get the cube root on its own. If I want to get rid of a cube root, we cube both sides, so that's 4x plus 3 equals 3 times 3 times 3, that would be 27. 4x, or subtract the 3, we get 24. Divided by 4, x equals 6. Right, then this one's more for the next unit, so don't worry too much about this one, but just understand the process. Right, then for number 17, the square root's already isolated, so let's go ahead and square both sides. We get x plus 15 equals, alright, so this we have to FOIL. X times x is x squared. X times negative 5 is minus 5x. We got minus 5x again, plus 25. Combine the like terms, we get x squared minus 10x plus 25. Right, so now, this is a trinomial, so we have to set it equal to 0, so subtract the x, subtract the 15. We get x squared minus 11x plus 10. Then we got to factor this. So we got to find two numbers that multiply to 10, add up to negative 11. Right, so those two numbers would be negative 10 and negative 1. Right, so when you set these each equal to 0, you get x equals 10, x equals 1. Alright, then number 18, it's the same process. This one's a little bit harder. You would square both sides, you get x plus 2. You would FOIL this. You get x squared minus 36x plus 324. Let me just make sure. 18 times 18, yeah, 324. Then we have to set this equal to 0. So subtract the x, that's minus 37x. Subtract the 2, that's plus plus 322. Then we got to find two numbers that multiply to 322, add up to negative 37x. Alright, so to find factors, you could always do 322 divided by x and y1, go to the table. Everything here multiplies to 322. Let's find the two things that add up to, hold on, that should be 322, subtract, that's 322, yes. Let me see. Alright, this one should, yeah, so here we have 14 and 23, those add up to 37, so it would have to be negative 14 and 23. Yeah, negative 14, negative 23. Alright, so x equals 14 and 23 when you set them equal to 0. Alright, then let's just check if this works. Square root of x plus 2, x minus 18. Alright, so 14 does not work, 23 does. Alright, so now for the last part, 19, not the last part, but 19, they set up the table and graph for you based off this scenario. So they gave you what goes into y1, y2. They gave us a table. They gave us the graph. The solution would be where the y1 and y2 are the same. So that would be when x is 8. It's also where the solution is right here. All right, same thing on 20. This would be x is 7. On 21, this would be set up as square root of negative 14x plus 2 equals x minus 3. And then looking at the table, looking at the graph, they don't intersect. There's no y1, y2 that are the same, so this would end up being no solution. And then for number 22, what is the solution set for the equation? So on this one, let's use a graph. So let's graph both sides on here. So x minus 6 is just a straight line with the y-intercept at negative 6, slope of 1. Right, and again, you could use the calculator to graph the right side on here. So it would be this line right here. Right, then for this side, we got a vertex at 2, negative 2. Alright, so again, you can just do this. So we just did x minus 6. That's the graph. Go to the table, get your points. And then we need to graph also square root of x minus 2. Minus 2. Alright, so you just go to your calculator, get the points. We have points at 2, negative 2, 3, 1, and 6, 0. So here we can see that they intersect at 6, 0, so that would be our solution. Alright, so that is the end of the test review. Alright, good luck. Don't forget to like. Don't forget to subscribe and hit the notification button.